The purpose of this online video is to review the difference between the short run and the long run and identify the characteristics which economists apply to those ideas of short run versus long run. Next, we're going to talk about the law of diminishing returns in the short run, and then we're going to study economies of scale in the long run. For an economist, the difference between the short run and the long run is simple. In the short run, at least one resource is fixed. Typically, we call this the plant or the factory. So in the short run, the size of the plant is fixed. In the long run, all resources, including the size of the plant or the size of the factory, are variable. Note well that there is not a specific amount of time which relates to the short run or the long run. And the difference between the short run and the long run will vary for different industries. If we think about a business which is very labor intensive, it's a service business, but you don't need a lot of capital. You don't need a lot of machines and equipment to execute the services necessary. So for instance, a financial firm or an accounting firm. For this firm, the difference between the short run and the long run, the short run might be a very short time, say 2 weeks, where they could find a bigger office space, or a month at the most. However, if we think about situations which are extremely capital intensive, manufacturing firms such as automobile plants, for an automobile manufacturer, the long run might be as long as 7 years before a new factory can be built because of all the various ordinances of buying a piece of land and getting it approved and all of the paperwork and all the headaches of municipal laws and such. So for heavy manufacturing, the difference between the short run and the long run is typically a longer period of time. The short run might be 7 years, and the long run any period after that where the size of the factory can be expanded. Let's review this idea of the law of diminishing returns by looking at, in the short run, the period of time when at least one of our resources is fixed, the relationship between our variable input labor and our fixed resource capital. In column 1, we simply have the units of labor. So from 0 to 8, that's the number of people working, and we can say per day in this factory. Column 2 is simple enough as well. Column 2 just brings up the total number of units produced. Obviously, there is a correlation between the number of people working at the factory and the number of people and the number of products produced each day. Column number 3 is extremely important. Column number 3 is marginal product. Marginal product can be defined as the change in output or the change in total product associated with our change in labor input. So what happens when we have 0 people working? Obviously, we produce 0 units of output. Total product is 0. But when we hire one person and this person goes to work in the factory, look what happens. Total product increases from 0 to 10. So the marginal product, the change in total product associated with this first unit of worker, is 10. Likewise, if we add a second worker, total product increases from 10 to 25. So the marginal product associated with the second worker is 15 units of output. And then finally, as we add another worker to our factory, total product increases from 25 to 45. So the marginal product associated with the third worker is 20. The change in total product associated with the third worker is 20. Over this range of first, second, and third worker, the firm is experiencing increasing marginal returns, which simply means each successive unit of labor input adds more to total product than the previous labor. And this should make sense because as you add people to the factory, they can specialize, they can share jobs, and of course, more gets done. But unfortunately, because we're dealing with a short-run situation where the size of the factory, the firm, the plant is fixed, we can't continually increase our labor input and expect total product to increase. So beyond 3 units of labor input, the firm begins to experience diminishing marginal returns, which means that the next worker, in this case the fourth worker, adds less to total product than the previous worker. If you notice, the marginal product of the fourth worker is 15 units of output, because total product went from 45 to 60. So that fourth worker increased total output by 15. The marginal product associated with the fourth worker is 15 units. This does not mean we would not hire the fourth worker. It simply means that because in the short run, the law of diminishing returns is unavoidable. You can't continually add a variable resource, labor, to your fixed resource, capital, and expect increasing output. The factory starts to get cumbersome. Notice that as we add the fifth worker, the marginal product of the fifth worker is only 10, and the marginal product of the sixth worker is 5. We would never hire beyond 6 workers, because notice what happens. The marginal product with the 7th worker is actually 0. In other words, that person is standing around doing nothing. And with the 8th worker, things have become so cumbersome in the factory, people are bouncing into one another, and the 8th worker actually decreases. In other words, there's negative marginal returns if we add an 8th worker to the factory. On the far right-hand column, we have the average product column. Average product is a measure of efficiency. We simply take total product divided by units of labor, and we come up with our average product. Now, there's a unique relationship between these three: the total product, the marginal product, and the average product, and we will see this in graphical form on the next slide. So now let's reinforce this idea of the law of diminishing returns and the relationship between the total product curve, the marginal product curve, and the average product curve. The top graph demonstrates the total product curve, and you can see labor input is measured on the horizontal axis, and total product is measured on the vertical axis. So 1, 2, 3, 4, 5, 6, 7, 8, 9 along the horizontal axis, the x-axis, measures the number of people working, and the vertical axis, the y-axis, 0 through 30, measures the total units produced. So notice that as we add workers, the first, second, and third worker, initially total product increases at an increasing rate. We can notice down bottom the relationship between marginal product and average product as well. The marginal product of the first worker is 10, and the second worker is 15. The third worker is 20. So if marginal product is increasing, we will have a situation where total product is increasing at an increasing rate. Notice that beyond the third level of workers, diminishing returns begins to set in. That is to say, the fourth worker contributes less to total output than the previous worker, the third worker. The marginal product of the fourth worker is a bit less than the fourth worker. Again, this is simply an economic phenomenon which exists because in the short run, the size of the factory, the size of the plant, is fixed. We cannot continually add a variable resource, in this case labor, to our fixed resource, capital, and expect output to increase forever. Beyond the third worker, this firm is already experiencing diminishing returns. It does not mean we wouldn't hire the fourth worker, because look, up top, total product is still increasing with the fourth, the fifth, and the sixth worker. Even though the firm is experiencing diminishing marginal returns, total product is increasing. Now this sounds funny, but it makes a lot of sense if you sit and think about it for a moment. When the firm is experiencing diminishing marginal returns, total product is increasing at a decreasing rate. I'll say that again. While the firm is experiencing diminishing marginal returns, total product is increasing at a decreasing rate. That is to say, the marginal product associated with the fourth worker is less than the third, and the fifth worker less than the fourth, and the sixth worker less than the fifth. But total product is still increasing. Beyond 6 workers, this is no longer the case. The marginal product of the 7th worker was 0, and beyond 7 workers, the firm would never consider hiring the 8th worker because negative marginal returns set in. That is to say, total product actually decreases because the factory has gotten so cumbersome. Notice that marginal product intersects average product at its highest point. The red marginal product curve intersects the average product curve at its higher point. This makes sense mathematically because marginal product measures the change in total product associated with the next worker. If marginal product is increasing, it's going to pull up the average. When marginal product begins to decrease, it's going to pull down the average. In the previous slide, we examined the short-run relationship between our fixed resource capital, which is the plant, the factory, and the machines inside of it, and our variable resources. And in particular, we looked at the variable resource labor. And we looked at this short-run relationship from the standpoint of production. In other words, as we add more workers to our factory, how does it affect output? And we established the law of diminishing returns. Now we're going to examine that same short-run relationship, the relationship between our fixed resource capital and our variable input labor, but we're going to do so from the standpoint of cost. Up on the board here we have 4 cost curves, and we'll go through them respectively. Let's focus on the green AFC, average fixed cost, first. Now remember, what is a fixed cost? A fixed cost is a cost that does not vary with the level of output and is unavoidable. So in other words, it does not matter how many units of output the firm produces, this cost will be the same regardless. So a good example of a fixed cost is the rent on a building. A good friend of mine owns a bakery. I was just speaking to him a couple weeks ago about it. Does he open every day of the week? And he said he used to take off on Mondays because his rent was less expensive, but now his rent pretty much works out to be $100 a day. So that's a fixed cost. He says he can't afford not to work anymore because that fixed cost is so high. So it doesn't matter if he produces 1 million cakes and donuts and danishes per day or 0 per day, the fixed cost is the same. Another good example of a fixed cost would be insurance premium. The insurance company does not care how many units of production take place each day. The fixed cost of the insurance premium will not vary with the firm's level of output. So fixed costs are unavoidable and do not vary with the firm's level of output. For this particular example we're examining on this slide, the firm's fixed costs are 100. You can see that at one level of output, the firm's average fixed cost is 100. So that would be a good way for you to understand what we mean by fixed cost. A firm's average fixed cost and its total fixed cost would always be the same at 1 unit of output. Notice how quickly the average fixed cost curve slopes downward because this refers to the idea of spreading out the overhead. Average fixed cost drops from 100 to 50 when the firm increases production from simply 1 unit to 2 units. And then obviously average fixed cost drops to $33.33 with 3 units of production. So as the firm produces more, average fixed cost will drop. The remaining 3 curves on the board are actually the most important cost curves when understanding cost to the firm and the theory of the firm, and we will spend some detail going over these particular cost curves. Let's look first at AVC, average variable cost. The average variable cost curve is the yellowish looking curve. It's a U-shaped curve. It reflects the law of diminishing returns. So what are the firm's variable inputs, variable cost? The variable costs are labor, utility bills such as how much electricity or how much natural gas the firm uses, raw materials. Those are your variable inputs. So initially average variable costs are a bit high. They begin to diminish and reach a minimum, and then beyond some point begin to rise. So your average variable cost curve reflects the law of diminishing returns. The average variable cost is calculated by simply taking total variable cost divided by quantity of output. What about average total cost? Well, if we combine the green average fixed cost and the yellowish average variable cost curve, we come up with the firm's average total cost curve. Notice it reflects the combination of the shape of the average fixed cost curve and the average variable cost curve to come up with the average total cost curve. Likewise, this curve represents or this curve demonstrates the law of diminishing returns. It has a similar U-type shape. Average total cost is important because it combines all of the costs. It helps us understand in the short run the firm's cost perspective when taking into account average fixed cost and average variable cost. The last cost curve is extremely important, the bluish-greenish marginal cost curve labeled MC. Notice that it also has a U-type shape. And also notice that the marginal cost curve intersects average variable cost and the average total cost at their minimum points. What is marginal cost? Marginal cost is the cost of producing, the change in cost, I should say, of producing one more unit of output. So anything marginal thinking is always going to be change in something. So the marginal cost of the firm is the change in total cost associated with producing one more unit of output. Notice that marginal costs begin quite high, diminish quickly, and then start to rise. Again, the law of diminishing returns. More importantly, if the change in total cost of producing the next level of output is lower than the previous level of output, the marginal cost will obviously be lower, but notice it also brings down the average variable cost and average total cost. So in other words, in the short run, when marginal costs, the cost of producing the next unit of output, are falling, it will bring down the average variable cost and the average total cost for the firm. Beyond some point, the marginal cost of producing the next level of output, the next unit of output, will begin to rise, again because of that idea of the law of diminishing returns. In the short run, the size of the factory is fixed, and we can't continually add our variable input labor to our fixed resource capital and expect costs to continue to lower. What about changes in costs? In other words, what happens if the firm's rent were to increase? Which cost curves on this particular graph would be affected? Well, if the firm's rent were to increase, the average fixed cost would increase and the average total cost curve would increase. Both of those cost curves would shift upwards. What happens if labor cost or raw material cost increase? In this case, the average variable cost curve, the marginal cost curve, and the average total cost curve would all shift upwards. It's important to have an understanding of how these curves would shift upwards or downwards based on changes in cost to the firm. Obviously, when we start looking at theory of the firm and competitive market models in the next chapter, anytime there's a change in cost, it's definitely going to change the firm's potential profitability. We have spent some extensive time examining the firm's short-run decision process. We examined the short run from both the standpoint of production and the standpoint of cost. Now we're going to adjust our thinking and look at the firm's long-run analysis. Now remember, what's the difference between the short run and the long run? In the short run, at least one resource, typically the size of the factory or the plant, is fixed. In the long run, all resources are variable, even the size of the factory. The long run and the short run is not a specific time period. This will vary with the industry we are analyzing. In other words, accountants differentiate the difference between the short run and the long run as 1 year. Anything longer than 1 year is the long run. Anything shorter than that is the short run. This is not the way economists view the world. To an economist, the long run is simply the period of time in which the firm has time to adjust the size of the factory or the plant, where all resources are variable. And this will definitely vary with industries, different industries. So for instance, heavy manufacturing, airplanes and automobiles, the long run could be a significant amount of time. There is going to be an entire process that is connected to the time period between when a large manufacturing automobile firm like Ford Motor Company, GM, or Toyota decides to build a new factory and when the factory is actually up and running. It would take one of those corporations maybe 7 or 8 years to adjust to a new factory because they would have to buy the land, they would have to get all kinds of permits, there would be all kinds of zoning issues. There would be all kinds of court cases. Next, the plant would have to be built, and of course, it would have to be equipped. So for the automobile industry, the long run might be 8 years. So, what about long run production analysis? Well, because all costs are variable, what we have to do is we have to build the firm's long run average total cost curve. So, the reason why it's different from the short run average total cost curve is because in the short run, we run up against that idea of the law of diminishing returns. We start to outgrow the effectiveness of our factory because it has a limited amount of size. So in the short run, we're always butting up against the idea that we can't continue to add our variable resource labor to our fixed resource capital and expect output to increase. But in the long run, even the size of the plant is variable. So let's look at how we build the firm's long run cost curve. Let's examine all the way on the left here where it says average total cost on the vertical axis, right? And at the bottom, the horizontal axis analyzes output, the firm's number of units produced. If we look also up on the left at ATC, average total cost -1, average total cost curve 1, that's the exact same shape as the average total cost curves we analyzed in the short run. A matter of fact, this is the firm's initial short run average total cost curve, ATC-1. So ATC1 is the firm's first or initial short run average total cost. If we think about this logically, beyond some level of output, the cost of production begins to rise for any firm in the short run because of the law of diminishing returns. When costs begin to rise, it's a signal to the firm that they should expand the size of the plant. In other words, they should grow, become even bigger. They should build another factory. So how do we derive the firm's long run cost curve? Is simply we analyze each of a series of the firm's potential short run average total cost curves and then combine these short run average total cost curves to derive the firm's long run average total cost curve. So notice that the firm can continue to lower output costs, lower cost of production in the long run by successively building larger and larger facilities or adding new facilities to existing facilities. So the firm can escape that idea of the law of diminishing returns in the short run by making the size of the plant or the factory bigger in the long run. However, notice beyond some point, even in the long run, costs begin to rise. In the next few slides, we're going to examine what's called the law of economies of scale, and then why even this economies of scale is inescapable in the long run. Let's examine this economic concept referred to as economies of scale. In the long run, all resources are variable, including the size of the plant. So the firm has the opportunity to make the factory bigger in the long run. This leads to lower unit production cost, especially when we examine situations of industries that are large-scale manufacturing. So for instance, airplanes and automobiles. Automobile manufacturers can reduce the unit cost of production by sizing up mass production. So what are the four economic rationales behind this economy of scale? The first one is labor specialization. In other words, you can have one or a group of people performing a specific task over and over again. Obviously, the more someone performs a specific task, the more efficient they become and the better they become at that specific task. Sometimes economists refer to this as economies of scope, the idea of getting better at something because you've done it many times. Likewise, that drives efficiency because you can have much more productivity with people who are experts in one area and leave other manufacturing tasks to be performed by people who are better at specific tasks. So labor specialization. Managerial specialization is also available. In other words, If you pay someone $125,000 to manage 10 people in a small manufacturing facility, they could easily manage 100 people or even 1,000 people in a much larger facility. Especially when you consider today there are ways to measure the efficiency and the work being performed by each worker, each laborer, with all kinds of automated tools measuring how many units they produce per hour or per minute, how much actual production takes place at their workstation. Likewise, we have factories with all kinds of cameras and all kinds of computerized tools to measure efficiency. So one person can manage many more people on a large scale, and you're paying fewer managers to manage more people. Efficient capital is an extremely important idea. The best example of this is in the automobile industry. It used to take somewhere in the neighborhood of 7 hours to fasten the chassis of an automobile to the frame. There's a new stamper that costs somewhere between $30 and $35 million. This piece of machinery, obviously extremely high upfront cost. But if you're going to produce hundreds of thousands of automobiles per year, obviously the investment in that machine is well worth it. It reduces the time of that function being performed from somewhere in the neighborhood of 7 hours to somewhere in the neighborhood of 7 minutes. So obviously a huge upfront cost there as far as the capital investment for the firm, but using it efficiently over mass production significantly lowers per unit costs. Now there are other factors that could be in play here when we talk about economies of scale. The one is simply the idea of, after you've invested in, made a huge investment in starting up the company, you get much better at tasks over time. We're going to examine this idea of economies of scale, looking at a graph, and then we're going to talk about the idea of minimum efficient scale and constant returns to scale on the next few slides. When we examine this particular slide, what do we have? Okay, cost per unit cost is on your vertical axis. Level of output is on your horizontal axis. SRAC 1 on the left-hand side upwards refers to short-run aggregate cost curve. Short-run aggregate cost, so average total cost for the firm. So notice that when this particular firm is small, they are operating on the short-run aggregate cost curve SRAC1, and they reach a minimum average total cost for this short-run analysis at AC1 on the vertical axis when they are producing Q1 level of output. Now notice, beyond Q1 level of output, the firm's costs begin to rise again. So this signals to the firm that because they need more productive facility, because in the short run diminishing returns starts to set in, right, that in the long run they're better off expanding. In the long run, there is no law of diminishing returns because even the size of the plant is variable. So what we do here is, again, like we did on the previous slide, we're simply deriving the firm's long-run average cost curve from a series of short-run aggregate cost curves. So for this firm, they can continue to expand from one size plant or one size factory to the next and reduce per unit cost by taking advantage of this concept of economies of scale, because in the long run, even the size of the plant is variable, and those four factors we referred to on the previous slide allow for economies of scale to take place. So notice mass production, when this firm reaches the third plant size, they've significantly lowered per unit cost from AC1 all the way down to AC3 when they produce Q3 level of output. What is minimum efficient scale? Okay, this is an important idea. It's the lowest level of output that a firm needs to produce to achieve the lowest long-run cost per unit of production. So in other words, does the firm need to produce 50, 100, 1,000, 2,500, 50,000 units of production until they reach that minimum level of per unit costs? Now, this is an extremely important idea because it really can determine the structure of an industry. If a firm can reach minimum efficient scale, the lowest level of cost, average cost, by producing not too many, in other words, say 100 or 200 level of output, it's going to open up the industry to many competitors. This would resemble something like furniture manufacturing, where you don't need to produce on a massive scale to really reach that minimum efficient scale. You might be able to produce 300 sets of couches and chairs, or tables and chairs, as far as production, in order to reach that lowest long-run average cost. This is in juxtaposition or completely opposite than the situation we analyzed in the previous slides when we talked about automobile manufacturing. Because automobile manufacturing requires enormous investment in capital, the firm's going to need to produce massive amounts, far greater numbers of output to achieve this minimum efficient scale. So in situations where minimum efficient scale is reached at a lower level of output, there's going to be more competitors in that industry. We are going to examine industries in the future. We typically refer to this as monopolistic competition, where there's a large number, or at least a significant number, of producers competing. If minimum efficient scale is only achieved by the firm when they produce a significant number of output, if the lowest long-run average total cost is only achieved at a very high level of output, the industry is going to resemble a situation where there are far fewer producers competing, and economists refer to this as an oligopoly situation, where there may only be 5 or 6 or 10 manufacturers competing in the same industry. We are now going to combine our definition of economies of scale and the previous slide's economic idea of minimum efficient scale to examine different shapes of long-run production cost curves, long-run average cost curves. Notice, again, we have our cost being calculated on the vertical axis here, average cost, an average total cost in the long run for the firm, and on the horizontal we have level of output. This long-run average cost curve demonstrates a situation where the firm continually can reduce per unit cost over a long or large level of output. In other words, the firm continually enjoys lower and lower level of per unit cost over a significant amount of production. Let's look at 2 points on this curve and then discuss what these points represent and how this will affect the industry. So obviously, the firm can continue to lower per unit costs as they increase production output. This would be a good example of large-scale manufacturing like the automobile industry. At Q2 level of output, right? So let's say you were actually measuring cars produced per week. And let's say Q2 represents 5,000 cars produced per week. If this firm produces 5,000 cars per week, its average cost per car would be at AC2. You can see that on the vertical axis. Let's assume that AC2 is $20,000 per car. All right, $20,000 per automobile. Well, notice that the firm can significantly reduce average cost per car, per unit cost, by increasing output, by taking advantage of that principle of economies of scale, by taking advantage of labor specialization and managerial specialization and efficient capital that we discussed on the previous slide. So increasing output from Q2 to Q1 reduces per unit cost from AC2 down to AC1. So let's assume that per unit cost dropped from $20,000 per automobile down to $15,000 per automobile, a significant drop in per unit cost. So for this particular firm, the minimum efficient scale is all the way out at Q1. A firm must produce Q1 level of output to achieve that lowest long-run average total cost, the minimum average cost per unit. Now, how is this going to affect the industry? Well, obviously, let's assume that several manufacturers already exist in this industry and are already achieving economies of scale because they are producing at a massive rate of production. They're already achieving mass production. So they're producing at Q1 level of output, and they're enjoying a nice low average cost per unit at AC1. What happens when a new firm tries to enter this industry? Notice that it's going to be extremely challenging, if not impossible, for a new firm to enter this particular industry because they would need to ramp up production in their first year all the way out to Q1 level of output in order to come even close to competing in this industry. If the new firm produces at Q2 level of output, right, their average cost per automobile is going to be significantly higher. Now, obviously, unless they can pass on that cost to customers, it's going to be challenging for them to be profitable in this particular industry. So now you understand why certain industries are dominated by a few very large players, when you can name globally the manufacturers of automobiles off the top of your head. How about a different situation? Notice the shape of this long-run average cost curve. All right, economies of scale exist in the long run, but notice that if a firm produces at Q1 level of output, or anywhere between Q1 and all the way out to Q2, right, this is what economists refer to as constant returns to scale. In other words, the per unit cost along that entire range is the same. So in other words, a firm can produce Q1 level of output or anywhere between Q2 level of output, and the per unit cost, the average cost per unit of production, is going to be roughly the same. Now, for all firms, eventually they would start to run into this idea of diseconomies of scale, which we're going to examine on the next slide on why this occurs, why even in the long run a firm sometimes experiences diseconomies of scale. But let's talk about first about that wide lime green range there where the firms are achieving or experiencing constant returns to scale. So anywhere between Q1 and Q2 level of output, the average unit per output is the same. Now, why is this the case? Remember when we defined minimum efficient scale a few slides back, we talked about a situation where small manufacturing, light scale manufacturing, in other words, a firm doesn't need to produce 100,000 units to achieve the lowest average total cost, the minimum average total cost in the long run. The firm could produce maybe 100 or several hundred units of output. And something like shoe sales would be a good example of this, where obviously, there is some startup cost in producing high quality shoes. Where you need a factory, you need machines, you obviously need some type of manufacturing system, but you don't need to produce millions of units in order to achieve minimum efficient scale. Likewise, like we used in the other example, furniture. Right? A furniture company can produce several hundred units in a relatively modest sized factory to achieve the lowest or the minimum average cost per unit. So this industry is an interesting industry to analyze because you can have both massive competitors who produce hundreds of thousands, if not millions of units per year, and you can have smaller manufacturers which produce far less, both competing in the same industry. And the key fact here is that this opens the door to competition. In other words, a firm could start up, enter this industry, and within a reasonable amount of time produce at Q1 level of output, and therefore be competing on the same playing field as all the other firms in this industry, the medium-sized firms, the large firms, and the enormous firms. We examine the idea of economies of scale, that in the long run the firm can continue to decrease per unit cost by growing larger mass production, and we looked at the economic rationale behind economies of scale. Then we looked at a situation where economies of scale were achieved quite quickly, minimum efficient scale was achieved quickly, and actually experienced or existed for quite a significant level of output before costs began to turn upwards again. We also examined situations where economies of scale continued to be available. The firm could reduce or lower per unit cost for quite some time, and then eventually would reach minimum efficient scale. But even in that situation, average per unit cost would eventually turn upwards. So in all situations, the firm may run into this idea of diseconomies of scale. In other words, growing too large. And the economic rationale behind this principle actually makes a lot of sense. The idea of control and coordination problems. We talked about one manager on a manufacturing plant looking over 10 or 20 or 100 workers. Well, remember, there's multiple activities taking place on a production floor, probably on an extremely large scale that none of us even think about on a daily basis. And, it's good to be excellent at performing one task, but however, somebody has to oversee and coordinate the entire process. So growing too large can create a problem where there's a disconnect between activities taking place in one part of the floor, one part of the factory, and what needs to take place in another part of the factory, right? Which leads actually to the second problem, this idea of communication problems. What's taking place on the factory floor today as opposed to what needs to take place on the factory floor tomorrow. Think about large-scale manufacturing like the automobile industry. There's significant investment in design. In other words, continually making the car better, more fuel efficient, more safer. However, the people involved with the process of developing and designing automobiles, engineers and such, are not the same people that actually either manage the tasks that take place on the production floor, or obviously not the people who produce the cars. So sometimes there's a disconnect between each level of production, between the design, the implementation, and the actual production which takes place of manufacturing. The last two have to do with sort of human nature. Worker alienation. In other words, sometimes when the firm is so large, Joe Q worker does not feel as if they're appreciated, or may feel a significant disconnect between their part of the production process and the actual product. In other words, if you think about a situation where there's a small manufacturing firm, you may be involved with multiple stages of production. Heck, some workers may be involved with all stages of production, where they can actually enjoy the fruits of their labor. They see where their work takes them and how it has something to do with the finished product, and they can take some pride in that finished product. If you work at a workstation and you rarely ever, if never, see the finished product, there may be significant worker alienation. And the last one has to do with the idea of shirking. Let's be honest, sometimes human beings are lazy. In other words, there's an opportunity to say, well, that work is good enough, or I've done hard enough work for today, or there's no way that the manager on our floor can accurately assess how much work I'm doing in 8 hours. So there's an opportunity for people to sort of take advantage of a situation where there's significant amount of sort of downtime to be had if you know what you're doing, stay at lunch too long or such. So for these 4 reasons, diseconomies of scale could plague the firm.